Hello, I'm Channa Bankapur. I'm going to discuss my solution to the lead code problem smallest integer divisible by k. It's today's daily challenge in lead code. The problem definition is we have a positive integer k and we need to find the smallest positive integer n such that n is divisible by k or k divides n. And n only contains the digit 1. That means it has only ones 1, 1, 1, triple 1 likewise. It's a decimal number, but it has only ones. And n can be pretty large. That's why they're asking us to return the length of n. And if there is no such n, we are going to return minus 1. And they also indicate that n could be pretty large. So n may not fit in a 64-bit signed integer. By the way, 64-bit signed integer can hold about 18 or 19 decimal digits, not more than that, right? So there is another constant here. K can be as much as 10 power 5, and we can we'll see that n can have thousands of digits, right? So that's why 18 or 19 is actually too small a number, and using even a big integer kind of data structure is also not a very good idea. Maybe we can use that, which is not going to be an efficient solution. But yeah, I think LeetCode is not expecting such a solution using something like that, a big integer kind of data structure. I'm going to use some number theory principles that should be helpful. I'll start with the brute force idea. The idea is I'm going to start with the smallest possible value of n, which is 1, and it has a length of 1. So we need to figure out a n where k can divide n, right? So the first such n. So we are going to have a while loop here while k does not divide n. So k divides n is something like this. This is the symbol we use in number theory, and k does not divide is shown like this. So as while k does not divide n, we need to keep finding new values of n. So I'm going to increase the length of n every time, as long as we don't find such a n. So how do I get the next n? N is going to be n into 10 plus 1. So when we find an n which is divisible by k, so we have a length already, so we are going to return that length, right? So this idea looks pretty simple. It's kind of a brute force idea, but it's not actually correct. There are at least two major issues. One issue is we already figured out n can have hundreds or thousands of digits, right? So this operation of n equal to n into 10 plus 1 is kind of not is not going to work that easily. So what do we do in number theory? In actually in modular arithmetic, we have a concept of using a modular value, so that we are not going to deal with the infinite values of these n. We are going to deal with only the finite values. So if you use this modular of k here, so everything is going to be inside k. So why it works? Let me show you that. So I'm going to use mod k here. Wherever a new n is computed, I'm going to use mod k. So that way, all the values of n are in this range of 0 to k minus 1. Okay, why this is good enough in this case? Essentially, n belongs to this kind of possibilities. Why this works is all we need is to see the divisibility of n, right? Whether k divides n or not. If k divides n or whether doesn't divide n, if I remove some multiples of k from n, it's not going to affect the divisibility here, right? So that property is useful from number theory, so that we don't need to worry about bigger values of n. Any value of n can be mapped to these k different values of n, right? So that's how this problem can be simplified. Now we are going to deal with only a simpler value of n. Obviously, we need to keep track of the length. That's why I have another variable called len here, right? So that is going to keep track of the actual value of n, but the n we see here is going to be a modular value, right? So in that case, this condition also is going to be different, because when k doesn't divide n, it essentially means n is not equal to 0, because when k divides n is going to be 0, because we are taking it as an n mod k, right? So that's why it is going to be 0 when it divides. So as long as n is not equal to 0, we need to do this. So that issue is solved, dealing with larger values of n. There is one more issue, which is, what if we don't have an n where for a given k, because k may not actually have any n which can be divided by that. So in that case, we need to return -1, right? So where are we handling that? So if there is no such n for a given k, this while loop is going to run indefinitely. All right. So yeah, we are not going to find that value at all. There are multiple ways of catching that. One of the ways is we know there are only k different values of n, right? N can have only k different values, and the while loop we don't have to go for indefinite number of times. At some point, so if the while loop runs for say k number of times, we know for sure it is already repeating. That means if you get a same value of n once again, so this is the only place where n is changing, right, in the loop after initialization. So if you get the same value of n, we're going to be doing the same thing, right? We are not doing anything different, and it's not going to end. So we'll be in a cycle. So that's why if you get a same value of n once again, we can actually stop and say there is no solution. So one way of catching that is if the loop runs for k number of times, I'm pretty sure it's not going to run for more than sorry. I'm pretty sure there is already a cycle. Cycle might have already occurred much earlier, but I'm not detecting that. I can detect in using some other ways by keeping track of the possible values of n which are already we have seen. That's going to take some extra space. But here I'm going to use if this runs for k number of times, I'll stop and say there is no such value. So this condition is going to be a little different. So as long as n is not equal to 0 and len is lesser than k, because when len becomes k, we don't have a solution, right? So when I come out of this one, all I need to see is if n is equal to 0, then only we have an answer which is len. If it is not equal to 0, that means we must have come out of because of that len condition. So in that case, I'm going to return -1, right? So yeah, this idea of catching here, you can actually see the pigeonhole principle being used here. All right. So the pigeonhole principle idea is um, so the pigeonhole principle idea here is so if there are only like k number of pigeons here, and there are more than k pigeon so k number of pigeonholes and more than k number of pigeons, so obviously it's going to repeat, right? So it's a very simple principle to understand. um, Otherwise, what we have used here is we have used some principle of number theory to start with, and within number theory we use this modular arithmetic. So these are the concepts which are helpful here. Otherwise, once we know this idea, the whole thing is going to be very simple. If you observe the loop, it works in big O of k time, right? Because this loop can run at the max k number of times, because when len becomes k, we are going to stop. And we don't take any extra space, it takes big O of 1 extra space, right? If I use some other logic to capture no solutions, in that case we might need some extra space, right? Here we don't need that. All right. So I hope everything is clear. I'll just show the code, which is extremely simple, what we have discussed here already. Look at this. I've started with n equal to 1 mod k. Why I'm using mod k in that line number 4 is what if k equal to 1? I could have handled that case as a special case, but just to handle that case, I'm using this as mod k. If k is equal to 1, n is going to be 0 here itself, and it will not get into the while loop, and it will return uh, you know um, 1 as the answer. All right. Let me submit that, and yeah, it is accepted. All right, let me see how much time it takes. Yeah, it works pretty fast, right? It took negligible amount of time. Yeah, this is pretty much the fastest way of doing it. All right. So if there is any other way of doing it, please let me know. There are multiple ways of solving this problem. Yeah, otherwise, please like the video and subscribe to the channel. Thanks for watching.